So it's all quiet. I hope I'm not at the origin of this silence, and I hope you will have a lot of questions at the end. So I'm Cyril Gambini. I will talk for 45 minutes, I hope not more, about a tool that we built at Neosoft Technologies. As you may hear, I'm French, so my English is not 100% perfect. Don't hesitate to make me repeat if needs be, and I will surely ask you to repeat your question because there is a great chance that at first I don't get it. So I will just share my screen if I can. Yeah, here's a button. And so to complete the presentation, I'm Cyril Gambini. So I'm a TestStand architect. I'm a LabVIEW architect, and since few days, I'm a LabVIEW champion. And I work for Neosoft Technologies. Neosoft Technologies is based in Canada, in Montreal and in Quebec. We've got 2 offices there. I've been working with LabVIEW for more than 15 years now, and I don't like to talk too much about it. That 15 is a number way too high. I've been working in France for 8 years for 2 different partners, and now I'm working for Neosoft Technologies in Canada since 2016 now. So as you may know or may not, we are DQMH trusted advisors at Neosoft Technologies. So we use DQMH a lot, and we also use TestStand a lot. So we came with the idea to find a way to combine TestStand and DQMH and try to find if it was a good match to use DQMH with TestStand. And so we found out that actually there was some pros and cons, and I will talk about that a little bit later. And so we came up with a tool that help us remove, or at least try to remove the counts of using DQMH with TestStand. And that tool is called DQMH TestStandifier. There's a great sentence here, adapt your DQMH modules to be efficiently called from TestStand. So actually, efficiently is our way to see it. So it's a personal opinion of how we should use or DQMH modules within TestStand. So that opinion can be discussed, and I hope that you won't hesitate to discuss it. So I will do a quick introduction to TestStand and DQMH because I don't know if the audience know TestStand and DQMH, so I will be quick on that just to set the base here. Then I've presented at the GLA Summit last year about the pro and cons of using DQMH with TestStand. I will just do a quick recap so we can understand where the tool comes from actually and why we built it. And then we'll go through the scripter. So the TestStandifier, there is a scripting part that allows us to modify the DQMH module. And then we'll see that we go with that tool from the DQMH module to a set of files that we'll be using with TestStand. And then we'll just try to see what are the pros and cons of using this tool. And hopefully you will have some questions. Otherwise, it will be a good time for another coffee, I guess. But first of all, I would like to start the presentation with the presentation of a female engineer. Actually, Julie Payette was Canadian, previously Governor General of Canada, former astronaut, engineer, scientist, corporate director. I hope I'm not missing another role. I'm sure she has. She flew 2 rocket missions. And she actually spent more than 25 days in space. And she is, maybe like most of us here, she has a Master of Applied Science in Computer Engineering, or at least she is an engineer early in her career. So when I see that I have some problems just driving my car, I'm pretty impressed that she actually flew into rocket missions. Yeah, that's it. So a great woman. Then we dive into TestStand. So the fun part just ended, and here we go into TestStand. Actually, I just want to make a quick clarification. TestStand is actually not a sequence editor. TestStand is an engine. It's an engine which allows us to run test sequences and a little bit more things. You can handle user managements and type managements and a few things like this. And on top of the engine on top of TestStand, you have actually UIs that allow you to create sequences or to run sequences, scissor execution and things like this. You've got one main UI that is shipped with TestStand when you install TestStand on your computer, which is a sequence editor. So I just want to make the differentiation between the engine and the UI. And TestStand actually allows us to through adapters to call some codes. So you can call LabVIEW VI, C, C++, DLL.NET assemblies, Actix, now Python. And you've got a palette with few flow control steps, if else, for loops, while loops. And since you create sequences, you can call with sequences thanks to sequence calls. And you can handle databases to store results. And you've got some few options for synchronizing code execution between sockets. TestStand, the engine allows you to run the same code over one UT or several UT at the same time. So you've got process models to handle this. And also TestStand comes with a few IVI steps and switch executive steps. So you can actually control your instruments natively for IVI supported instruments. The purpose of TestStand is that you execute scripted sequence, so it's not a compiled code, so your sequence can be modified on the fly, and you can write the sequence, call whatever sequence dynamically if needs be. And the purpose of TestStand is at the end give a status for a specific UT. Is the status good or not? Was the sequence terminated or did an error occur during the test execution? And you will be able to get some result recorded, and you can create reports automatically and store that to database. And one of the force, as I said earlier, is that you can handle one or several UT at the same time through process model. So you've got batch or parallel process model when you are testing several UTs at the same time. And TestStand automatically duplicates your sequence. So if you have 16 UTs to test, you don't have to create 16 sequences. You only have to create one sequence, and TestStand will duplicate it 16 times in memory and execute the sequence. And one very important slide here, and it will come. We will see that it has an impact when using DQMH modules into TestStand. That TestStand is actually through adapters, letting some other runtime engines to call code. And while an adapter runs, TestStand waits, actually. So it gives to an adapter some parameters, and it says to the adapter, hey, run this code and let me know when it's finished. And if it doesn't have any feedback, it just waits, and it can wait forever. You should handle termination within a step, actually. What is termination is that, for example, an operator decides to stop sequence execution and press a stop button on the UI. Since TestStand is waiting for the code to return, you have to handle that request within the step. So you can stop the step execution. We can see here we've got a sequence execution monitoring VIs, and if the user press stop, there is a true values flowing here that stops the while loop, and since the while loop is stopped, TestStand can get back the ends on the execution and actually nicely stop the UT test. Also, a very important thing here, step may produce error. An error is different from a failure. an error is that, for example, you've got an instrument and the instrument is not responding anymore. And so TestStand cannot execute correctly, and the step would produce an error. And in case of error, TestStand cannot say that your UT is good or is good or not. It's just an error. So an error is very specific when testing a UT, and it doesn't allow you to give a great feedback or on the UT state is good or not. TestStand doesn't know when you say an error happened. So you have to catch errors in TestStand, like you would catch errors in LabVIEW, for example. You have to do that work in TestStand too, and that's often not done very well in TestStand because it's can be complicated. But we've got some callbacks to help, and we'll see that we will try to leverage that with the DQMH TestStandifier. And also a step may produce data and TestStand may collect or not this data to produce reports. And that's it for TestStand. And then DQMH, I don't know if any of you use DQMH. I see only a few of you or other people on Teams, but yeah, I've seen Leah. I know she uses DQMH, but maybe just for those who don't know what DQMH is a toolkit that is freely available and you can download it thanks to VIPM. And it's maintained by a consortium, which means that there is no private interest in developing DQMH. It's a bunch of folks doing this to support DQMH and enhance how DQMH runs and updates the functionalities that you can have with DQMH. It's just an extension of an IQMH. Actually, if you compare an IQMH to DQMH, you will see a lot of difference. Basically, it works the same inside, but the communication with the module is done thanks to events. So you can send requests to a module, and it will maybe, if you want to, answer with some results. The idea of DQMH is encouraging the same style between different developers, which means once you know how DQMH works, you can just get a module made by somebody else and you will understand how the module works quite easily. They all work the same. And if you want more information, I've got here a link that I will share after the presentation. A module, what's a module? A module is a LabVIEW library, actually, with some core items. You've got actually one main VIs that you will put your intelligence in, or your main code in the main VI, and you've got a tester. A tester allows you to send requests and get feedback, and the idea is that you can simulate from an interface how your module behaves when you send some parameters and see what are the results that it can give you back. And communication are seen through events. There are three main kind of events, actually four. I just seen that I missed one. That's not good. You've got request and reply, and you've got run trips. And actually the fourth one is broadcast. A broadcast is just a way to receive a status from a module. And run trip is a request and reply plus a broadcast. So this is quite interesting. The run trips here, most of the DQMH users only use request and reply in broadcast, but not so much run trips. And we will see that actually I use run trips a lot when I use DQMH with testing. And we'll see that after, and I will try to explain why. And we've got two execution patterns. You can create singletons. Singletons are modules that will be the only one in memory, not duplicated. It's not possible to duplicate it, actually. If you try to run a second module that is second singleton, it will actually return the information that the module is already running, and it will not be duplicated. And the clonable is if you want to run several instances of a specific module. Actually, if you make it clonable, you can. Quick GLA recap of why using DQMH with TestStand. I've got a YouTube video here if you want to see that topic in depth. But just to summarize it, you can create your DQMH without TestStand in mind. For example, you want to have an application and you want to create a module to control a specific instrument. You just want to create your DQMH module to control that instrument, and you don't want to think about TestStand. So you just create your module, use a tester to ensure that everything's working fine, and then you can think of porting all that into TestStand and not design specifically for TestStand. And also, you can access the tester from LabVIEW and from TestStand. So you design your module, you call it from TestStand, something bad happens, and you want to use a tester to get some feedback to display the broadcast of your DQMH module. So tester will work whether you call it directly from LabVIEW or directly from TestStand. So when it works on LabVIEW, you port it, and you can call it from TestStand without thinking too much. Actually, we'll have to think, and we'll see that after, but I mean, it's possible. Also, it forces you to create atomic step by design. Atomic step, I mean, one step, one responsibility. You create an API, actually, to send requests and get feedback from a module. And since you create an API, you've designed the API to be atomic, to only handle one thing at a time. So it's pretty good with TestStand, because TestStand, you've got single steps that you call one after the other, and that should only do one thing. I've seen many TestStand design where a single step does a lot of things, but that's bad design. So if you use a DQMH module and you create requests, by default, you've got a better design, since your step won't be doing 1 million things only in one step. And you can keep a context outside of TestStand. So for those who want to retain some values in memory with TestStand, it can be somehow tricky. TestStand have several variables with different scopes: locals, file globals, station globals, and you can abuse some variables. And I've seen projects where the developers were just storing everything in station globals. It's like a global in LabVIEW. I mean, it works, but not the best way to do it. A DQMH module have a data cluster that you keep into the module, and that helps you keep context of the data that you want to retain. So instead of storing everything in TestStand, you can keep a little bit of memory inside the module. It helps. And also, it's easy to create helper loops in DQMH, so you can do continuous monitoring into your module. You can do this directly in TestStand also. You can run sequences in parallel, but you have to think about stopping them, etc. And then the API of TestStand just for that is sometimes not the best. And for a LabVIEW developer, it's maybe easier to create helper loops inside the module instead of dedicating a TestStand thread just to do this. Since you've got singletons and clonables, it matches quite well between DQMH and TestStand when you have one or several UUTs to be tested at the same time. So you can use clonables, for example, to handle a UUT communication. And if you have 16 UUTs suddenly to test at the same time, you can have 16 clonable modules to be put in memory. So I mean, it's a good match here. The way DQMH works and TestStand is a good match. You have to think about launching and stopping your module from TestStand. I've had some customers wanting to start the modules and stop the modules from a UI and have TestStand using only the request to call things out. I call this a bad design. We can discuss about it, but if you do this, your sequence is then very hardly coupled to your UI, which is not what you want most of the time. But I mean, that's feasible. My advice is not to do it, and you should launch modules from TestStand, and you should stop them. Also, you should use round trip and road trip. I'm glad they exist in the DQMH modules. A round trip is a request and reply plus broadcast. So if you've got a problem in TestStand when sending requests to a module, you may open the tester and you may want the feedback of yes, my sequence sends that request, and here is the feedback from the module to my sequence. And sometimes you just don't handle very well the reply in TestStand, and the test is failing, etc. And doing round trips for everything, you've got like a debug flow which comes naturally into your tester. So it doesn't add much, just a broadcast that is added, and it gives you a lot of values when debugging your system. So since you are calling your request from TestStand, and sometimes it's hard to stop the TestStand execution to pose it exactly where you want. Most of the time when you are using or testing several UTs at the same time, it's hard to only stop one UT, for example, and not the others. And so using round trips is a very good way to get some more debug info when calling DQMH from TestStand. So I will try to go a little bit faster, but the pros, I've talked actually about it, but you can launch module from a TestStand. It's actually 2 steps, start and sync. So you only have 2 VIs to throw into your sequence. You still have to think about syncing your modules. This is not optional, so it's not 1, but it's 2 steps to head. But I mean, not that bad. You've got access to all the default requests, so you can still show and hide panels of your DQMH modules. You can see the diagram. You can still stop the module and do a lot of things manually as you would in LabVIEW, and you've got access to this into TestStand. So you do not have to develop specific things for that. And also testers can be used while the execution is running, so to capture broadcasts. So that's why I said that you should use round trip, just to get a lot of feedback into your testers when running this from TestStand. So it helps really for debugging. You should be careful of automatically calling the tester actually from TestStand, because tester is a blocking VI. It's a while loop continuously running. So as I said earlier, if you try to launch the tester from TestStand natively, it will just block the execution. So be careful of that, and also be careful with the UIs. If you call a DQMH module into a UI and also into a sequence, when you will create an executable, your UI and TestStand will run into the same namespace, and you may have conflict there. So it's very useful, but be careful. It can be a pro, it can be a cons. You have to think about it. Steps in the sequence are lightweight, so actually your active code is not running into the sequence, only the requests are. Okay, so you're just sending requests and getting feedback, and the actual code that would control, for example, a PSU or whatever, is not running into the sequence. So it's really lightweight. It will help for loading, for example, your modules or your sequence in memory. When starting a new UT, you can actually start quite fast. It's a prompt, but it can be a cons also. We'll see that after, because the actual code is not running into the sequence. It's running in parallel into the module. Clones fit well with parallel testing, and singleton fit well with single socket, and also parallel testing when you want to create a controller. Counts. You must think about stopping the module. That seems trivial, but in TestStand it's not. A TestStand retains a lot of memory, so if you're not stopping the module and try to restart again sequence execution, you may have some you may have some problems with memory not being reinitialized correctly, for example, or with singletons not not running again, not running fresh. It will just keep the singleton already in memory and run it again. Same thing with the clonable modules. With the clonable module, you know that, for example, if you are using the DQMH, there is a module ID that allows you to identify a specific clone. And if you launch several times the same sequences, the module ID will just keep incrementing Why? Because TestStand do not release its memory every time you run a new sequence. It will keep in memory a lot of things and try to reuse them just to speed up the sequence execution, and it will keep that in memory. And so the module ID is generated thanks to a feedback node inside the DQMH module, and it will just keep incrementing again and again. So you will have to think about this. Your actual code is running into the main VI, which is running in parallel of the sequence. So actually, if you pause the sequence, it's not pausing the DQMH running code. So your code is running again and again. If you have a problem in your module and it keeps sending orders to an instrument, for example, without stopping, it's not because you pause or stop your sequence that it will stop actually executing the DQMH module. So you have to think about this also. How do I stop really the execution? Can I really stop the module? How do I do this? That's quite an important topic here. And also, if you are changing a request to a run trip because you didn't think about calling your module in TestStand at first, it will change the prototype, and changing prototypes of steps called in TestStand can be a nightmare. You may have to manually refresh every single call to that step, and it's quite long and not a fun thing to do. And so again, the action is not in the step, only the request is. As I said before, launching a tester is a blocking action from TestStand, so you have to think about how you want to launch a tester from TestStand, or otherwise you would just be blocked and you will have to abort the execution. Stopping a sequence in execution can be tricky because, as I said, you are not stopping the sequence only, you have to stop also the module. And also, error handling can be done in several places. Actually, when you create a DQMH module, everything about errors can be handled into the DQMH module, but you have to think about sharing that error to TestStand. Otherwise, you will be missing some errors actually, and you won't be able to handle correctly how to react to this error within your test sequence. And also, if you are testing several UTs and using clonable modules to address each one of these UTs, there is no way naturally to align a test socket index to a module ID. So in TestStand, the test socket index identifies a specific execution for a specific UT. And on the other side, you've got module IDs that allows you to control your LabVIEW code. And you may want to align both of these to say, okay, I'm calling a UT test socket index 0, and I need to send my request through the DQMH clonable module 1, 3, 4. So you would have to create a lookup table just to align things, and it gets messy most of the time, and it's pretty hard to do this. And we'll see that with the TestStandifier, we found a way to fix that. And so finally, we are speaking about the TestStandifier itself. So this TestStandifier comes into two parts. Actually, the main part is a scripter that tries to address all the counts we've seen right before, and modifies, and it will modify a DQMH module to try to remove some of the problems you may face when using DQMH with TestStand. The scripter tool actually performs 10 actions. First of all, and we'll see that in action right after, it validates the DQMH module. The first version of the TestStandifier was given to a friend of us wired in Australia, and I know that these are they integrate DQMH and TestStand. They've got experience with that. And Stuart, one of the developer, was really good to find bugs. Found 1 million bugs with the first version. Most of the bugs were related to DQMH modules being adapted, not the way it should. So the tester was like removed from the basic directory part VIs were modified and things like this. So they had a bunch of DQMH modules that were not valid DQMH modules, and we ran into bugs because of that. So now we are validating the DQMH module first. So with DQMH comes with a validator. So if you create a module, you can run a validator on top of that module, and several tests will be performed to ensure that your DQMH module will run well and correctly. So the validator is actually invoked from the scripter. Then if your DQMH module is valid, we create a source distribution. Why do we do this? I will just explain that after, but the idea is not to touch the original module. The idea is to work on a copy of your module, and we want a complete copy of the module, so we create a source distribution. Then we modify the request and replies at the test and termination monitoring, and I will explain why we're doing this into the request and reply. We insert the tester into the modules library, and then we create a PPL from the modified code. So this way, you've got one single file holding the complete environment needed for your DQMH module to run. And instead of having a bunch of VIs to deploy, I don't know if the TestStand developer here went through the TestStand deployment issues, but it's really a nightmare. So the less files you have to deploy, the better it is. So we create a PPL, so we got only one file to deploy actually. And then we create a sequence file and sequence call to actually create an API for the API. So we create a TestStand API on top of the LabVIEW API. Why do we do this? We think it's easier. The sequence adapter actually is one of the most powerful adapter in testing. You've got a bunch of settings on top of the sequence call. So we create that API. So even somebody not knowing LabVIEW won't have to deal with LabVIEW VIs. They would just have to deal with sequence call, and pretty easier. And then we map automatically the VIs input and output to sequence parameters. So your API is already ready to call the DQMH module. You've got nothing to do there. And we create code to launch and sync a module that really tackles the problems of aligning a socket index to a module ID when calling clonable modules. And we create code to automatically launch and stop the module tester. And we create also an error callback, so you won't have any excuse not to handle errors into TestStand. So it's much more to force you to handle errors. Here I've got a quick video of how it works. It's been accelerated, so actually we point on a project, and from the project we list all the DQMH modules that we find in there. So you pick one and you TestStandify it, and we can see here, oh, it's been fast. Oh, sorry. We can see here that the validation will occur. So here it's very much accelerated. It can take up to several minutes. Damn it, I've got problems with my video, I'm sorry. It can take up to several minutes to validate the modules, but it depends on how big your module is. And once the module is validated, we create the source distribution, and then we start modifying all the codes that needs to be modified. So all the requests and reply will be modified to actually integrate a TestStand monitoring execution monitoring system. And we'll put the tester, as I said, into the library, etc. Everything is done by scripting. You don't have to do all that. For a specific module, it can take up to 2 or 3 hours just to do the work that the scripter does in 10 minutes. And then when it's done, you've got the library created and the sequence created, and I will show you that in a few minutes, a little bit more in detail. So the tester does all that for you. Even creating the sequence file is done automatically. As I said, and it's very important, the source distribution ensures that all the ecosystem and dependencies of the DQMH modules are taken into account and will be present into the PPL. So that's why we are creating the source distribution here. And it also ensures that all the modifications are applied on the source distribution. So your DQMH module, the original one, is left untouched. So if you are using Git, for example, to track your source code, you won't see any modification in the original DQMH module, which will help maybe developing your application. We find automatically all the requests and replies that you've created into your module. As I said earlier, we use a lot of run trips, but a run trip is a request and reply and a broadcast. So we also, just finding the request and reply, find that interesting part of the run trips. And we add automatically a TestStand monitoring system in the loop, waiting for an answer from the module. And to do this, why do we do this here? Actually, what happens most of the time is that developers using DQMH, they face sometimes timeouts, and you've got a default timeout in DQMH of 5 seconds. And what happens is that, okay, I've got a timeout, I will just double the timeout. And they go from 5 to 10, and from 10 seconds to 1 minute to 10 minutes and whatever. But what we've seen is that when you add more and more time to your timeout, you actually wait here. And if you wait here, you are just waiting in that in this primitive here, and you're stuck into that VI. And if you want to stop the execution, you can, because as I said earlier, you are inside the LabVIEW adapter here, and TestStand waits for the VI to return, but there is a chance that this VI will return in 10 minutes because the timeout is so high that it will wait until the timeout occurs, actually. And this is not acceptable in production. When an operator just press the stop button, you want to stop, actually, the test execution. So as a scripter, takes the original timeout. So if you've modified the timeout from 5 seconds to 10 minutes, this is the original timeout that you've modified yourself. And we had that function in the middle, which splits the timeouts into chunks of 100 milliseconds. So we are running that for loop as much as necessary to wait and controls the execution of TestStand every 100 milliseconds. So instead of waiting 10 minutes, for example, because you've modified timeouts, you can actually stop within the 100 milliseconds. Why we do this here and not in the main? That's a common question. I don't want to touch the main VI. The main VI has been tested. And I don't want to modify your code. I just want to modify the way we are interacting between TestStand and the DQMH module. So we are actually stop. We stop waiting for the module answer, and we will have a problem doing this, actually. So if we stop it in TestStand, you are terminating your execution. And if you are terminating your execution, since you have to stop your module, you will call a stop module action, and you will have to handle this situation into your module. But without modifying the main core VI, we will be able to address here an execution termination requested by an operator without waiting too much. And so tester is inserted into the module library. So the tester is into the PPL. So you've got one file, and that file also ends tester. And so you've got one file to deploy, and it creates a new namespace. I've talked earlier that customers that was who were scaling the DQMH module into the UI and the same DQMH module into the sequence. It can create weird things because of the namespace. Building LabVIEW pack library just had a P into the name of your VIs that you are calling, and it creates actually a new namespace. So you are not mixing anymore DQMH modules that you are calling from your UI and DQMH modules that you are calling into your sequence. So these guys are some independence between the code which is called into the sequence and the code that is called into our UI. And since we create a sequence and we've got subsequences for each request, so if you create 100 requests in your DQMH module, it will add 100 subsequences into your sequence file. And you will just have to create sequence calls. So if you want to, I don't know why, but you may want to perform some requests in parallel. For example, since it's a sequence call, you will be able to do this natively into TestStand, for example. And we map all the VI input and outputs to sequence parameters, so you don't have to deal with LabVIEW and TestStand mapping. It will be done automatically by a tester. Also, I've talked about DQMH clone module ID and the way to link it to the test socket index. Actually, in DQMH, what you've got is that feedback node here, and it keeps incrementing the module ID. The scripter modifies it, and we had a Boolean, I'm sorry, the code is not really readable, but it's scripting. I don't know if you've done some scripting yourself, but the code created is sometimes ugly. It works, but it's ugly. So you can force, thanks to that modification of the start module VI, you can force the module ID you want your module to have. So it's not anymore an addition of +1 that is made automatically by the DQMH module, but you can actually force it from TestStand. So you can pass the test sequence index to that start module, and your module ID will be aligned to your test sequence index. The test sequence index is something that you can have from your execution, so it will be really easy to always talk to the same module from a specific test socket. So it really helps on how to communicate with a specific module ID to target a specific QT into your sequence. And this is a flag that you can activate or not. So if you don't need it, you just turn that flags off, and the start module will behave like any default DQMH start PI. And we create code to launch and stop, and this is really important, and stop the module tester. So we create a sequence call that is running in parallel, so we instantiate a new thread in TestStand. So when you launch, when you call a subsequence to launch the tester, it will run in parallel, actually, of your main execution. So the tester won't be blocking anymore your execution, and that's done by default. And we had a problem with that, is that when the TestStand execution was done and everything was closed, the tester was still running because it was running in parallel. And the only way to stop a tester in DQMH is to click on the red cross of your tester window. That's not a nice way to do it. There is no API to do this. So the TestStandifier modifies things, and we had a stop action, so you can actually also close the tester from your execution. So you can dynamically launch a tester and dynamically close it, which is kind of very useful when debugging in production. And we create a post-step runtime error callback to enforce error trapping into TestStand directly. And so we generate all that files on disk. I can show you here is a virtual machine that we use, and I've run the TestStandifier on it and to create my bunch of files. This is a log file when we create the PPL that we generate also thanks to the application builder. I don't know if you wanted to building PPL before, but sometimes you've got an error saying that you can't build the PPL and you don't know why a dependency is broken and things like this. We found out that the NI error message is pretty bad. And if you just activate the build log, you've got a bunch of information very useful in there. So the tester, the the TestStandifier actually creates that log file. So if you've got a problem building the PPL, there's a great chance that you will have the information of why it failed in there. So that's something you have by default with TestStandifier. Here is the pack library of a module, and here is a sequence that is actually generated. I should have launched TestStand before, but you will see that nice splash screen. So we've developed that in TestStand and LabVIEW 2017, but it works with upper versions. And this is the sequence that you get, and you've got all the basic API that you can find into a DQMH module. And here is, for example, a request. I've got a wait X seconds request just for testing. And we see that the VI is called from the pack library automatically, and we've got everything mapped nicely on the parameters also automatically. The parameters types will be aligned on the LabVIEW types, and you don't have to do anything. So if you want just to call that wait X seconds request, you just have to add a sequence call and just point onto that file, which is maybe here, and because I'm not pointing on the good one, here we have, and wait X seconds, and you here can feed the parameters dynamically from here. You don't have to care about the VIs in the DQMH module behind the scene. It's just the basic test encodes that you have to call, and you can feed that. We can see that the parameters are also set by value or by reference. By value or the input, and by reference or the output. So you can directly see from TestStand what is an input and what is an output also. And everything is there. And that sequence, this is a sequence file post-step runtime error callback that we had. So if you have a round trip and the round trip is creating errors, you have a placeholder to handle that error into TestStand and actually handle it here. So it also enforces good error management into TestStand. So you have no excuse not to trap the error, even the placeholder is created automatically. And here are the pros and cons that we have that we see with the TestStandifier. Actually, the original DQMH file are untouched. So your module logic and all the tests you've done before with LabVIEW are still valid, and we did not modify this. The module core logic, the main VI, is not modified. So we did not modify at all the main VI. Every modification are made into the request, and we are modifying the way the requests are handled, but not the main VI. So all the tests that you've made, unit tests or functional tests that you've made on your DQMH module are still valid. The TestStandifier did not modify it. It's quite fast. Like I said, a TestStandifier, when it runs, it takes 2 minutes of validation and then 2 minutes to generate the sequence file and modifications. So in 4 or 5 minutes, you've got a job done. If you have to do it manually, it can take several hours, depending on how big your module is. So it's quite good. And you enforce error management to TestStand. The counts problems we have, and we try to fix in V2 if there is adoption of that tool. The post-step runtime error callback is generated blank each time, so there is no update. If you already have an updated generated a module through the TestStandifier, you will have to generate again because you've modified your DQMH module. If you added code into that callback, you will have to save it first and copy paste into the newly generated system. So that's only one manual thing to do still. Maybe later we will have an update option. We do not support broadcast, native broadcast into the TestStandifier. I'm against this. This comes to the question, but this may come into V2 because we had feedback that people would want to support broadcast, but we don't actually. And actually, I don't need it. So maybe in V2 we'll see that broadcast support. And if you are converting modules that are calling other modules, it's not easy. You have to convert, like as you would do with PPLs, calling sub PPLs. You would have to convert the low-level modules first, replace them into the caller module, and then TestStandify the caller module itself. So again, it's a manual action here. Converting all the modules automatically would need to bring some recursion into the TestStandifier, and that's not an easy one. So maybe in V3, I don't know. But these are the counts that we see with the TestStandifier, and compared to the pros and the time earned using the TestStandifier. I mean, today we live that the TestStandifier is used in several projects in production and working quite well up to date. And I'm done. I don't know if anyone has questions. Or maybe everyone is sleeping. I know that when I talk about TestStand, people get to sleep quite fast.
Any questions in the room? Is the TestStandifier publicly available, or is it a product that can be bought, or is it free and open source?
Actually, we are currently one of my colleagues who's present here is working on developing or coding the VIPM deployment. So it will be available through a VIP. When we don't know yet, quite soon, because we are working on it. It won't be 100% open source. Some of the parts will be proprietary IPs, so it will be hidden into a PPL just to protect some part of the codes, but not everything. And we are thinking about a model today to distribute it. There is a great chance that it will come for free and distributed for free, and with the problems that you can find into it. Some of the part will be open source, but some others not. So I guess that in the weeks to come, you will be able to install it onto your computer. The purpose that we are, the goal that we have is to make it available as a LabVIEW tool and a TestStand tool. So when installing this with VIPM, you will be able to see it into our LabVIEW or TestStand ecosystem and call it from there. And it should be free. I'm not 100% sure yet, but it should be free to use.
Thank you.
Oh, I've got a question that I just thought, yeah, this looks really useful, and I do spend a lot of time wrapping LabVIEW code and TestStand. So yeah, this is definitely something I'm interested in. I was just wondering, I noticed when you wrapped, you came out of that sequence. Would you consider putting the sequence description as the VI description? Is that something you thought about?
That's a great question. I went through this, and actually, if I go there, if you start the module, you can see that there is no such sequence properties or comments or anything that is added. But actually, I'm calling directly the VIs themselves from the module, and everything should come into the VI. So it won't be hard to get to the VI documentation just diving one level into that sequence. And so adding much more steps just to copy that documentation into the sequence call was not that relevant to me, because it's not that easy. It's not that difficult, sorry, to get to the VI documentation directly.
Yeah, that's fair enough. Thank you. I've just got another question as well. I've stopped using PPLs in TestStand nowadays, because I find that if you've got PPLs that depend on PPLs and then you try and do a deployment, I find that you just get horrible cross-linking. I don't know if it's something that I'm doing wrong, but I was wondering if you tested that scenario. But TestStand deployment.
The first thing that I can say is, no, you're not doing anything wrong. Deploying or using the TestStand deployment system is hell for anyone. Okay, so there is a great chance that you are not doing anything wrong. It's just a tool that is really difficult to handle. And sometimes the behavior is not really explainable. Here, as you have noticed, the way we are enforcing it is that you have one DQMH module doing one thing, one responsibility for that one DQMH module, and having several PPAs related to each other, you would fall into that if you have a DQMH module calling several other sub-DQMH module, which is not something that we advise here. So you will have PPAs actually very autonomous and single PPAs not related to each other. So the coupling between PPAs should be reduced when you use the DQMH module, the TestStandifier, and your TestStand ecosystem. When you do this, most of the time deployment is easier.
Sure. Yeah,
deployment errors comes when you have couplings that the deployment tool cannot resolve. And when you run into this, you better try to find another way of deploying your system, but you can easily spend days trying to fix this. So
that's exactly the past. But yeah, that's useful. Stay away from that then. Thank you.
So yeah, it really depends on how you architect actually your system. But if you are following the way of creating one DQMH module with one responsibility and have it like autonomous, everything should go well.
Sure.
I've got a very basic question, because I've used LabVIEW and I have not used TestStand. Is TestStand the National Instruments standard way of creating unit tests and automatically running them to validate code? What does it do?
It's a test executive for large sort of racks of machines that you're testing. It's a test sequencer.
The hardware.
Oh, okay, so it's testing the hardware configuration and all that.
It's in factories testing stuff.
Yeah, as I said, haven't touched this.
Actually, I've seen people doing unit tests with TestStand, and I mean, there is also a natural fit between unit test and TestStand. You've got reports and you've got sanction at the end. It's pass or fail, so you can do it. It's the way, or I guess it's not the main purpose. TestStand has been created at the origin, but whatever you want to do with TestStand, you actually can. TestStand is just a sequencer. So keep in mind that it's just calling one step after the other, and you can add some spice on top of that, but the main purpose of TestStand is just that.
I'd say it's really useful when
you pretty complex.
Sorry, didn't mean to talk over you there. I was just going to say it's really good for scenarios. If you've ever tried to write code in LabVIEW where you've got like 20 units of the test and you're trying to, they might all take different amounts of time and stuff, and you're trying to code something that causes it all dynamically, TestStand will manage all of that for you, like if you set it up right. But it's a very sort of blank page system. There's 100 different ways of doing it, like in LabVIEW.
Yeah, it's just a case of you have all these hardware modules connected together in some way. You're expecting them to be connected together in a way which you specified, and TestStand is testing that they actually do talk to each other.
Yeah, so you just put in steps and then you've got decisions about what you do next. So it's a sequencer, if that makes sense.
Yeah, you're going through your setup and you're turning stuff on, turning stuff off, seeing what the response is and then doing something else based on that.
Yeah, as a test, yeah.
Okay. Awesome. Thanks very much, Cyril. Really, really good presentation. And we'll jump into this section, and obviously need to keep tech connected up. Yes.